Today we're going to work with solutions by inspection. It should look familiar to you because we've done it before when we did solving linear equations. So these will still be linear, but we are going to be in the form of, we want them in the form of y equals mx plus b. And then we're going to compare or inspect. So the first thing we're going to do is rewrite all equations. In slope-intercept form. And so that's this form right there. Once that's been done, we are going to start the inspecting. So the first thing that we want to inspect are slopes. That's what you're going to inspect, are slopes, okay? So we're going to inspect that letter M there. And if they are different, then there's going to be one solution. So if slopes are different, there is one solution. What this means is there's only one point where they're going to cross. So let's say that we graph our two lines and this would be their solution. Because it only crosses one time. So, graphed lines cross one time. So the key to this, and if you remember, you've actually done some, for those of you who've done your biweeklies, is that the slopes are different, but the y-intercepts, so that B, can either be the same or different. So if you remember, we did these on the biweekly where you'd have to replace the letter H and say, what could you replace H with so that it has infinite solutions? Or one solution, or no solution. So same thing. So you're always going to start the inspecting slopes. Okay, so maybe I'm going to put that right here. We're going to start inspecting slopes. So if slopes are different, one solution, automatically done. Okay, that means you're going to cross one time. But let's say that their slopes are the same. So the m's are the same. Because if slopes are the same, it's going to be one of these two options. And that's because the slopes are either going to be, everything will be the same, so the equations will be exactly the same. So slopes are the same and the y-intercepts are the same. That means that it's infinite solution. Or all points are going to intersect. And a lot of times they'll give you a picture on this. You guys will get it wrong because you're like, there's only one line graph there. So the reason is because you would graph that line and it's going to look like only one line has been drawn because they're all the same. If you have y equals 2x plus 3 and y equals 2x plus 3, you're graphing the same line. So it would be like this one, but usually they'll do at least another arrow so you can see there's two. But a lot of times it looks like just one line because if you graph them, they'd graph right on top of each other. So same slopes and same y-intercepts, infinite solutions. But if they have same slopes and different y-intercepts, that's when there's going to be no solution. That means that there will have no points. There will be no points where the lines are going to intersect. Our lines will be parallel. And parallel, the symbol for parallel is this. Sometimes they'll ask you, what does that mean? So that's parallel. And perpendicular is the T, the upside down T. So they're going to be, and I cannot, well, let me try to draw them straight with at least the highlighter. That means that we have one line that goes like this. and another line that would go like this. So we can see those lines are never going to cross. They stay the same distance no matter where I put, no matter where I count. So those are the three types you have. So you start inspecting the slopes. Are the slopes different? Automatically one solution. If slopes are the same, then we got to compare or look at their y-intercept. So first thing we have to do, step number 1, says to make sure they're in the form y equals mx plus b. So we have y equals mx plus b, y equals mx plus b. So now we compare. We start by inspecting their slopes. So right here, whoops, let's do it. This m equals 7 and 2. Since these are different slopes, we know there's one solution. So right now I'm not saying what the solution is. I'm just saying there's one solution. Once you graph them, you could tell me where they cross, and where they cross will be the solution because that's the ordered pair where they're exactly the same. So on this one, we make sure they're written in y equals mx plus b form, y equals mx plus b form. So then I'm going to compare slopes. These are the same. So now I have to compare the b, and one's a -5, the other is 5. So these are different. So this says same slope, but different y-intercept. So this one says same slope, same intercept. So that can't be it. This one says same slope, different y-intercepts. So that means that this would have no solution. In other words, when you graph these lines, they will never ever cross. And then our last one, again, it is already in the correct form, y equals mx plus b, y equals mx plus b. So we start by comparing my slopes. Both of them have a -1 in front. So those are the same. Then I'm going to compare my b's, and they're both 4s. So all same, infinite solutions. All right. So this is where we are going to find some of the things that people look at and think are tricky. This is Ava thinks lines A and B would have no solution because the lines do not intersect on the graph. Is she correct? Explain your answer. So A and B, here's A. And remember the arrows on the ends of these means that they keep going forever. Here's B. According to Ava, these are going to have no solution. Other than the fact I can't draw straight lines. Let me try to do it this way. With this one though. So here's pretty close. Here's my other one. Eventually, if I keep drawing those lines, what do you notice about my distance from here to here, here to here, here to... Is it staying the same? Or what do you notice my distance is happening to my distance? So Ava is wrong because they, even though they don't cross on here, they will eventually cross. So Ava is incorrect. So lines are not parallel. And I'm going to just do the symbol for that. So lines are not parallel. They will eventually cross. Now, if I said, how many solutions does line B and line C have? You'd say, well, there's one solution. That solution would be right here if we were looking at B and C, because they are going to cross one time at that point. Also, A and C cross right here. So they also have one solution, which means they have one solution. They had different slopes to begin with. All right. The next question is a context question. It says, Colin starts with $8.50 in his bank account, and he saves $15.75 each week. So this is his start. This is what he started with. This is what he saves each week. James starts with $7.50 in his bank account, and he saves $15.75 each week. Write an equation for each day. Write an equation for each boy above, and then tell if the two boys will ever have the same amount in their savings account. So I'm going to start. We want our equations in y equals mx plus b form. So I'm going to start with Colin. If we were to describe Colin, we know that he starts with $8.50 and he earns or is saving $15.75. So I'm going to put $15.75. He's earning that and he's putting it in each week. So if you want to change it, all I did is put my slope at the end here, or my rate of change at the end, because it tells me he starts with that much. Now, if I take James and write an equation for him, y would be the total amount he saved after however many weeks it's in there. James starts with $7.50 in his bank account, and he also saves $15.75 each week. So the question asks us, will they ever have the same amount in their savings account? And hopefully you're looking at this going, no. We know they're both saving the same amount every single week. So if they started with the same amount, then they would have the same. But will they ever have the same amount? No. Unless James starts saving more or Colin spends, they will never make the same. And the reason is they have the same rate of change. So our m or our slope is the same, but these are b value. So actually, let's put this. So starting points are different. So they will never have the same. All right. So now what you're going to do is you are going to figure out how many solutions these have without even graphing them. That's part of your assignment. The other part is I want you to write an equation that is, so they're going to give you your original equation. I want you to rewrite the equation so that it has one solution, no solution, or infinite solutions. So to have infinite solutions, no matter what, everything has to be the same. So all I'm going to do is write y equals 3/5 x plus 2. Because to have infinite solutions, my equations have to have same slopes and same y-intercepts, which they do. To have no solution, I know they have to have the same slopes, which they do. But up here, when it says no solutions, my equations will have the same slope but different starting points. So if I start that, this one starts at 2. So this one can start at 8, -4. It can just be any number in there. It just cannot be 2. And then our last one is one solution. Well, one solution tells me that our slopes are different. I don't care if my y-intercepts are the same, but my slopes have to be different. So this would be y equals x plus 8, or you could do x plus 2. What I'm going to be looking for is you first need to be able to compare your slopes. And then based on that information, you can tell whether your b would be the same or different. So let's do one more, and then you can figure out the rest on your own. All right, so this one, again, I have no plus b here, which means that it's a plus 0. Again, they're never going to write that because there's no reason to. So this one, if it's infinite solutions, my equation is going to look exactly the same. And you can put plus 0 there if you want. If there's no solution, my slopes will be the same, but my starting points will be different. So I could just say this one's going to start at 1. And if there's one solution, it just means my slopes are different. So maybe I'm going to make this one a -3/4 x. It could still be plus 0. It could be plus 6. It could be plus 8 million if I wanted. Just to have one solution, my slopes cannot be the same. All right, I want you to try these bottom ones on your own here and see How you do?